Welcome to the third part of the series where I am designing my own printer, based on the BLV. I had built a Cartesian printer couple of years back during those COVID days. I had ordered the Anet E12 but I was not too happy with it, so I decided to make it into an entirely different beast. This was my design, made entirely in SketchUp. The Anet E12 is nowhere in sight, but believe it or not, this was made from the bones of that printer. It had all linear rails, dual Z-axis and much more. But alas, like all us 3D printing nerds, I wanted more. There were a couple of things I did not like about this design, such as the use of printed parts for the main mechanics, the weight of the gantry, the non-existent cable management, and a few other minor issues. But the biggest problem I faced at the time was that the frame used non-standard extrusion lengths, which are hard to source. So I had to get the available lengths and cut them to size. All I had at the time was a Dremel, so you can imagine the quality of cuts. And that led to assembly issues and the frame not being square. That is why one of my main design criteria this time around is to use standard length extrusions. The BLV frame also does not use standard length, so you either get the frame kit, or you need to cut them down to size. That is why I am designing this printer with standard length aluminum extrusions. So getting on with the build, in the last part I had designed the frame. Now I am quickly modeling the linear rails for the X and Y. For the Z-axis, I have THK-SR20 rails from my previous build, and I intend to reuse those. So I am quickly going to model them as well. I am not making very detailed models of the rails because that will increase the face count. It can lead to a laggy viewport. Besides, I don't need the details as it will not affect the designing process. I just need the overall shape, but the dimensions need to be precise. With the rails modeled, I quickly align them with the frame. And then I model the print bed. At this point the size of the print bed is 380 by 350, which is what I had for my previous build, and I was intending on reusing it. I was planning on using a dual Z-axis, synchronized with a belt, same as my previous printer. But then I did a quick count of leftover components that I had and realized I could have triple Z-axis. And so I started working towards that. I have an SKR 1.3 board, so it does not have enough stepper drive slots to handle triple Z-axis. That was a bummer. Then I came across this expansion board by Big Tree Tech. With this I can have triple Z-axis along with dual extruders, and still have a spare slot. Only downside is, I will not be able to use a display. But with Clipper and mainsail web interface, I can live without a screen. So with a few tweaks to the design, lo and behold, triple Z-axis. The next part in line is the lead screw mounts. Normally the lead screw is resting directly on the stepper motor. A stepper motor has a compressible spring washer within it, so that introduces a play and can result in inconsistent layer heights. A simple yet effective solution is to use thrust bearings. So here I designed the lead screw to be resting on the thrust bearing. However, a thrust bearing cannot take radial loads, so I have to add another ball bearing for that. The lead screw will directly sit on the printer frame, and that will ensure extra rigidity. The motor can be mounted to the side, and with the use of belt and pulleys, it can drive the lead screw. An added bonus of the belt and pulley system is that it can provide gear reduction. So I will use 16-teeth pulleys on the motor and 32-teeth pulleys on the lead screw. That effectively doubles the resolution of the Z-axis. While it does not automatically translate to a better print resolution, because that depends on many other factors, it will ensure that a few missed micro steps will not have that much of an effect. In a nutshell, we get more consistent results. I also added anti-backlash nuts and Oldham couplings for good measure. The Oldham couplings ensure that any wobble in the lead screw is not transferred to the print bed. It effectively decouples the X and Y movement of the lead screw. The results of this are debatable, so that is something I am going to have to investigate further once I actually build the printer. I have designed the Z-axis blocks such that they can be easily printed but also easily made with aluminum flat bar. I am trying to minimize printed parts and trying to use metal parts where possible to improve the reliability of the printer. Now I need to attach the bed to the Z blocks. The most common solution is to use bed springs because they allow manual bed leveling, however the bed is free to bounce around. And this really affects the quality, especially for taller prints. I don't need manual leveling as the auto bed leveling and triple Z-axis will take care of that. There are few options out there like the linear rails of the Hevert, spherical bearings of the Voron Trident, or kinematic couplings of the Rat Rig. The Hevert system looks cool but would unnecessarily increase cost and complexity. I really like the kinematic coupling solution. It allows the bed to tilt freely with the Triple Z and also allows free expansion of the bed with heating cycles. And you don't need any additional extrusions. The bed sits directly on its mounting points. The hardware is also relatively inexpensive and easily available. You just need some magnets, dowel pins and threaded steel balls. I intend to use the Hermit crab tool change system with my printer. So here I quickly figure out a way to mount it to the carriage. It is possible to use the plates that came with the BLV metal kit, although I will have to drill some holes in them to mount the Hermit crab. Finally, I bring in an E3D hot end. That takes care of the major components of the printer design, but it is not even close to complete. However, it gives me enough to start my build. In the coming days I will start the assembly process of my printer and revisit the design as required. I will probably have to make many tweaks to the design. Once I have successfully completed the build and ironed out all the kinks, I will share the final design files of the printer. So stay tuned to follow the build log in the coming weeks.